Hi everyone, LO 2.1, capacitance and capacitors arranged in series and parallel. What's the difference between capacitance and capacitors? Capacitance is the capacity, how big or how small a charge can be stored, while capacitors are the electrical components. Now let's see what are the formulas that we need to use in LO 2.1. Alright, you can read this yourself, but I want to emphasize on this particular part. This is charge, the symbol is Q. This is coulomb, the unit for charge, and the symbol is C. This is capacitance, the symbol is C. And this is farad, the unit for capacitance, and the symbol is F. Do not get confused with C of coulomb, which is the unit for charge, and C for capacitance. Another formula that you might find while solving LO 2.1 is V equals YR. Different arrangement of capacitors in a circuit has different effective capacitance. This is for in series, and this one is for in parallel. Different arrangement of capacitors also affect the potential difference and the amount of charge stored in each capacitor. For capacitors arranged in series, the V1, V2 and the V3 will make up the total terminal voltage, while in parallel, V1, V2 and V3 are the same as the terminal voltage. For charges stored, the amount of charge are the same throughout all the capacitors arranged in series. But in parallel, Q1, Q2 and Q3 will make up for the total charge. Let's do some exercise. You may pause the video to read the question. Based on the question, I'm going to put here the 30 volt of power supply. Then I'm going to arrange the 3 capacitors in series. And these are the labels. Now let's find the effective capacitance first. They are obviously connected in series. 1 over CE equals 1 over C1 plus 1 over C2 plus 1 over C3. We substitute all the values. Thus, the effective capacitance is 2.67 microfarad. And since they are in series, all the charges are the same in each capacitor. Hence, Q1 equals to Q2 equals to Q3. Now, let's find the value of the charges stored. Q total equals to effective capacitance times terminal voltage. So, the charges stored in each capacitor is 80 microcoulomb. That's for question A. Now, let's do question B. Because they are arranged in series, the voltage for each capacitor is different. So we have to calculate one by one, like this. Do you remember still that when capacitors are arranged in series, the V1 plus V2 plus V3 gonna end up with the terminal voltage. Once you've calculated V1, V2 and V3 after this, try add them all together. You're gonna end up with 30 volt. Go ahead, give it a try.